me. I'm a boba. Oh, okay. I'm a boba enthusiast and have been to over 50 different boba shops before. So we'll get started. I'll tell you a little bit about the field that I'm interested in, specifically artificial intelligence. And this is the ability of computer systems to perform tasks that normally require human intelligence. And a lot of people often confuse this with machine learning, which is actually only a subfield of artificial intelligence. And I'll talk about that a little later. So the foundations of artificial intelligence are in data science, which is another field of computer science that uses algorithms to extract and apply knowledge and insights from given data. Okay, and going back to artificial intelligence, some of the major subfields include, but are not limited to, the ones on the screen, and I'll go into each in a little bit more detail. So the first one and the biggest one is machine learning. And you'll notice at the bottom of the screen, there's like YouTube, Instagram, Google Maps. These are all examples of applications of machine learning. So the YouTube algorithm, I'm sure you guys have all been on YouTube. You guys know that they give recommendations of videos based on what you normally watch. And so does Instagram and Google. They give you search recommendations. This is machine learning because it is taking the information that it collects from your previous search history and it's applying it to show you data that's similar so that you can have a better experience and maybe find things that you're looking for more easily. And the next field is computer vision. This is often used in robotics. So it can scan and filter the terrain around a robot. And the biggest example of this that I have is the Mars rover. I'm sure that you guys have heard of that as well. On Mars, the Mars rover can look around, it scans the area around it, and this uses computer vision, which is a type of AI. Next is natural language processing, and some good examples of this is Amazon Alexa, as well as virtual assistants that you usually see in the bottom right hand side of your screen when you go to a website. And these use artificial intelligence to understand human speech, or they understand like your human typing maybe. And this is done so surprisingly also through mathematical algorithms. I'm not going to go into detail, but if you are interested, you should search up some natural language processing. I think it's really interesting. The next subfield is deep learning. This one is a little more complicated, and it's actually only a subset of machine learning, but I included it because of how well known it is. Sometimes it's referred to as real AI because it's a lot of algorithms working together to create an artificially intelligent system, whereas other AIs might be more simple algorithms using just like math functions. But the major distinguishing feature of deep learning is that it's partially modeled after how the human brain functions. So in biology, you might have learned about the structure of a neuron, the cells that transmit signals in our central nervous system, which essentially dictate our thoughts and actions. You can see a model of it on the close to the bottom right of the bottom right hand screen. You can see the model of the neuron. And the signals go from the dendrites through the cell body and the axon to the axon terminals, where they are passed to another neuron's dendrites. This is similar to the neuron in deep learning, which takes input data in the form of pictures, words, or numbers, and it processes it in what is called the bias, and it gives an output which can be picked up by another neuron. The bias itself is made of mathematical functions to process the data in a way that can be simplified to a desired output. Now, if this doesn't make sense to you, that's completely fine. I'll give a simple example of how a neuron might work in deep learning. So for your inputs in this scenario, imagine that you're in a car, you're driving down the street, and you see a traffic light, or you see the red traffic light in front of you turn green. and you see all around you the cars have stopped. So in this case, you have two inputs, seeing the traffic light and seeing the other cars. And those go into your brain, and the bias, or your brain essentially, it processes the instructions of what to do. So in this case, it's doing you're thinking, you know that, oh, you see a red light turn green and you see all the other cars have stopped. So therefore you must do something. And that something is the output, which is accelerating to go. So how's this machine learning? When you combine a lot of neurons and link them to each other, it becomes known as a neural network. So either the inputs go to an output and the output goes to another input, or maybe multiple outputs combine together to become a single output. In either case, it's a neural network, and the computer uses this to filter information through layers, and it can become like an advanced set of instructions that work similarly to how your brain processes information. And also using other mathematical error functions, the machine would be able to adjust its biases, meaning it changes the algorithms in the bias. And this essentially makes the computer learn how to improve itself. So taking the output, doing some mathematical operations on it, and figuring out how you can modify the bias, that in itself is deep learning. And in this field of technology, you'll probably often hear that people train AI models and frameworks. It's a little confusing, but I think of this as perfecting a decision process. So the systems, they run over and over again until they are accurate enough for what you're doing. So they keep running, keep modifying the bias, and that's just perfecting a decision process. And remember, you don't want to over perfect it, because then it might be too catered towards a single data set, and then it wouldn't actually be like a smart AI. Now, what I do in this field, I've only really touched the basics. So I studied the basics of some of the major subfields. But one more specific thing that I've done was I researched and wrote a simple blog mini-series about generative adversarial networks, and that's another subset of machine learning. And I won't go into detail, but because I do not have that time, but we can move to the next slide. Great. So for my journey into STEM, my journey actually started in elementary school, but your journey can start at any point in time. You can start it right now, and even in 10 years, it's never too late to start. But I discovered my interest by playing on the home computer with my older brother. In elementary school, I also joined my school's coding club, and there were about 15 students, and we just learned the basics of Python, and that was like my first introduction to computer programming. Throughout elementary and middle school, I also built kits with my cousin. So we would have like small Vex robots or marble tracks. And then in high school, that's where it really started to develop into something that I had a passion for. So I started off high school freshman year. I took AP Computer Science Principles, and I was the only female freshman in my class. I think only about a third of my class was female. But the thing is, I never really minded being a minority in STEM. Sometimes I did feel a little out of place, but in general, I didn't really mind, because I was also the only female freshman to join my school robotics team that year. And again, only a third of that class was female. It was a little intimidating, but I became close with two other girls who joined that team that year as sophomores. And the three of us became known as a trio, as we became the new programmers of that year. My journey into STEM actually accelerated the most during the pandemic. I would say over 3/4 of what I know today come from this time. So the first thing that I did after school ended, I realized I had time for myself. I could do something cool with my time. So I self-studied for a C++ programming industry approved certification. And I spent like maybe 2 months working on it, or about an hour a day. And it just helped me learn how to self-study because I've never done something like that before. So then after that, I also started taking community college courses for programming and participated in a couple of competitions. This year, I was elected as robotics team president for next year. And actually, I was going through the application process recently with rising sophomores and juniors. So not including freshman acceptances, our team would have a female to male ratio of about 40%. That's a 10% increase from the year that I started, which is really impressive for an advanced robotics team like ours. Some other programs that I've been involved in, I did Inspire AI Scholars. After that finished, I became an ambassador and also a fellow. I'm also going to do an AI summer program this summer. I do have a referral link that you can use to get a guaranteed scholarship to attend the 4-day program for free. So if you'd like that, you can let me know. And I also started volunteering for the first time during this pandemic. So I found Robotics for All, a nonprofit organization, on Volunteer Match. I figured I had extra time, so might as well start volunteering. It has over doubled in size since before the pandemic. And right now I am a board secretary as well as an intern lead. Lastly, CodeDate is another nonprofit organization that has multiple programs, but I'm a contractor for CodeDate Labs, which is an internship style summer program where a group of 3 students are guided by a mentor to develop a professional project. I personally really recommend the program. I haven't gone through it, but I do see the back end of it and it's pretty impressive. However, most students who do it are undergraduate students, but they do take a few high school students who have completed AP Computer Science. So some of the benefits of technology. Technology is the future, but unfortunately, most girls have been missing out. As you can see, the world around us is developing to become increasingly automated and technology reliant. Especially through the pandemic, you can see how it has carried us through the time of being online or being digital, not being able to go outside. But on top of that, technology is a fascinating and stable career. It has countless opportunities and also a place for various types of people. Whether you're introverted, extroverted, or if you're detail-oriented, or if you rather look at the big picture of things, there is a place for you everywhere in technology. So also more developers in technology means we have more innovative ways to solve problems in society, or more interesting developments that improve your way of life or just for entertainment. And it's really cool to see them come to life. Unfortunately, women are underrepresented in technology due to gender stereotypes. I believe the only way to break these is to properly raise the next generation. Always remember that technology is not a boy thing, and you can do it too. So looking at the charts on the right, you can see how underrepresented we are. For example, the top right, artificial intelligence, one of the most cutting edge technologies, women only represent an average of about 20% of the industry. And looking at the bottom right, the major tech companies, women again also only represent an average of maybe 30% of each in each tech company. And seeing this underrepresentation, it's a little discouraging, and it might discourage future generations, which is why we should raise it right now and do what we can to close the gender gap, because it's really sad to see that girls are sometimes discouraged from pursuing technology when really we should be industry leaders as well. Right. And for my advice, you don't have to follow exactly my advice, and you actually shouldn't follow it because you should figure out what works for you. You should try different things, and if you don't like it, then don't pursue it. And if you do like it, then go for it. The first thing that I do recommend, though, is that you join or start school clubs. Um, some examples: Girls Who Code, any STEM club really, and robotics teams. So the first robotics competition or VEX. Those are some examples of robotics competitions. And really in school clubs, I think they're a really great place to be because you get to meet so many different people who all share the same interests as you. And you really build a community for yourself, and it's really fun. So next, I would recommend that you read articles that interest you and subscribe to newsletters. One newsletter that I recommend is the TLDR newsletter. This is an email newsletter. It's about STEM, and it summarizes new articles almost every day with only a paragraph and a link to the full article. I think you can search it up and you'll probably find it, but I find that it's really good to stay informed, especially about like new cutting edge technologies, and it's interesting to read too. Next, YouTube for self-learning and entertainment. One YouTuber that I do recommend is Mayuko. She's an Asian female YouTuber in productivity and STEM. The next tip that I have has helped me probably the most out of all of these, and that is using Google to search for opportunities. You have to be proactive, and Google, it's a great place. You can find lots of things like camps, conferences, volunteering opportunities, and competitions, specifically hackathons. Next is networking. This is really important, especially for like future jobs or anything. You reach out to people, and also you could find forums to join. For example, for me, I joined Built by Girls Hack Club and We Code Family, where they post resources all the time, and you also get to socialize with people from around the world. It's really cool. Next, I would take usually free online courses. Some of them might be paid, which is completely fine to take, but in my opinion, there's so many good free opportunities that I don't really see a need to pay, especially at our level, our entry level. For example, community college concurrent enrollment is free for all high school students. I highly recommend taking these courses. I started taking them at Pasadena City College, but really you can attend anywhere. And I really enjoyed meeting people who are in community college or meeting other high school students taking these courses. It's really interesting to talk to them and listen to their own stories. Next, I would take self-paced courses with sometimes optional paid certificates on platforms like edX, Coursera, or FreeCodeCamp. I've taken a couple or maybe one or two of these courses, and I got one certificate, but I realized that it wasn't really worth it for me to pay for the certificate because I wouldn't really do anything with it, and there is an expiration date. Lastly, I would follow your passion and keep a positive growth mindset. It is absolutely crucial that you keep a positive growth mindset because you're guaranteed going to fail. But keeping a mindset that accepts the failures allows you to get the most out of your experiences so that you can improve the fastest. Remember, you are not alone in your journey in STEM. Although much of it is self-taught and you will encounter obstacles, being proactive will extend your exposure to different aspects of the STEM field. And from there, you can pave your own unique path and eventually share it with others, as I have done with you. Reach out to me if you have any questions or if you would just like to chat. I'd definitely be open to talking to you.
Thank you, Danielle. That was amazing. Okay, so we're going to, hi, okay, you're muted, by the way, but you can start whenever you're ready.
Okay. Hello, my name is Rebecca Todd, and I'll be talking about technology in this discussion of the panel. Go ahead, next slide. Let me give you a little introduction about myself. I'm a thermal analyst at Northrop Grumman. One of the things that I'm highly interested in my career is the engineering portion of STEM. Some of my hobbies include just getting outdoors and just kind of exploring my world. So you can find me hiking or sailing out on the Pacific coast or any of these trails. And one interesting fact that I'd like to do in the near future is possibly get my pilot's and sailing's license soon so I can discover more of the world. Next slide, please. So let's go into it. So my field involves a lot of just creative thinking and as to why things happen. So as a engineer, we kind of design and build things for a purpose or a task. And getting into that field, you kind of need to be creative, learn how things work, why do things work, have the understanding and the fundamentals of just some of the basic fundamentals of physics to kind of go into this field. Secondly, being creative. Just I'm not necessarily an artistic person, but this is kind of the field where I get to explore my creative side. I'll start creating some different hardware designs or panels or, you know, something like that. And, if I can back it up with the why in terms of physics, it might work. Who knows? And also, I kind of like being close to being with the hardware. You can go, your whole entire career building something, putting stuff into it. But when you see the results and you see the hardware being built, that's kind of where I'm like, it's kind of coming together. So as a thermal analyst, what I do at Northrop Grumman is kind of help build designs for whatever the job is entailing for. And I mostly tell people, hey, this thing is too hot, it's gonna break, or hey, it's too cold, or it's gonna break. So I try to give and consult different members of my team to kind of figure out what is the best way to design whatever we're building, whether a payload or a vehicle, such that it can survive in the mission. And to get there, I have gone to college. I got my bachelor's in mechanical engineering, and I did a bunch of emphasis in heat transfer and fluid mechanics. There are three different modes of heat transfer. There's conduction, which is heat transfer between tightly packed molecules. And a good analogy for that is, your oven and a pan when you're frying something up, that heat transferring from your stove to the pan, that is conduction. The second mode of heat transfer is convection, which is a solid and a fluid flow. And going back to the pan example, as you're heating up your pan, let's say you have water in it and you want to boil your water, that mode of heat transfer is in convection. And then third and lastly, what I mostly work with at my job is radiative, which is heat transfer through radiation, which is in space. And most of the stuff that I've worked on goes into space, but you can get a career, in like Google and support their servers and learn how to cool their hardware in that terms. Or you can go to a car and learn how, their engines work and learning how to make their cooling fluid, circuits work. And so thermal engineering could just be applied to any discipline, and it's pretty versatile to where you want to go. It doesn't necessarily have to be kind of where I'm at, which is space. Some other applications to heat transfers that you might be near and dear to are, microwaves, pretty handy, uses convection, air fryers, and, refrigerators, which is a cold cycle. And then the kind of applications in space that I work with and I've had experience on in my career is, the James Webb Telescope, which is going to deploy and launch in October later this year. And I've supported a Cygnus mission, which are service stations for the astronauts on the International Space Station. So thermal engineering is pretty important wherever you go and kind of help, making everyday people's lives easier and just going to other planets or out into deep space. Next slide, please. So my journey into STEM. Well, what is it like being a woman in STEM? I have to say it was pretty tough. Um, it was tough because of the courses. You know, as a female, it's one thing. You're in a male dominant field. That's one thing. I think just for me, I was just more concerned about the knowledge. I really want to be an expert in my field. I really want to get the fundamentals. I want to make sure I am, competent and able to be highly competitive in this field. So a lot of it was just some of the knowledge transfers from teachers as I'm learning to myself. And, it is kind of interesting to see the demographic in the STEM field. Definitely, I know Danielle talked about it in having a disproportion from men to women, but I'm starting to see more females coming into STEM, and I'm encouraged to see that. And talks like this is very encouraging to bring young people, generations like yourselves, coming into the STEM, because we need more like-minded people and a diverse group of people to come through. We need more thoughts and ideas. Sometimes we get kind of stuck in the same idea, but if we don't give opportunities to different groups of people, then some of these ideas won't ever happen until someone says something. So, though it was tough, I made it through, and I know many of you will make it through as well. So, for me, when I discovered my interest, I was kind of unique. I was really young. When I was like 7, my mom gave me a Barbie watch for my birthday, and I was like, oh, cute. But then being very intuitive and wanting to know how things work, I actually took it apart. I got some screwdrivers from my dad's kit. I screwed it just like you see here, this little Barbie watch, the poor thing. I took it apart and I got to see everything that worked in it. And my mom, she came back and she was so upset. She's like, what is this? And I told her, I'm learning how this works. And she's like, can you put it back? And I said, no. I cried. Just kidding, I didn't. But, being curious and taking things apart, especially as a mechanical engineer, being close to hardware, just because you can't put it back together doesn't mean you're not learning. I learned a lot doing that. And, when I was smaller, I didn't necessarily have the vocabulary or understanding or people surrounding me to know that was engineering, but I knew I wanted to do this. And so I kind of kept continuing my curiosity, which goes to building IKEA furniture. I love building and being near hardware. That's what mechanical engineers do. We do a lot of designing and we're very intimate with the hardware. And so it is like a training ground for maybe young people. And I know some people hate putting things together, but I love it because it's a very efficient way of putting furniture together. And as an engineer, I can appreciate what the Swiss people have created. Yes, good job, Swiss, the Swedish. And um, what other additional experience has helped me further my interest? Well, being surrounded with like-minded people. Surround yourself with people who will encourage you to, be your best, or ask people who are maybe in this field and maybe ask them, what do you do? What do you like? What don't you like? Get a wide variety of people that you want to see. Growing up, I honestly didn't grow up with any engineers, and I learned this very late in the game in college. I didn't know I wanted to be an engineer. I just know I like math and I like science. And that was just the amount of vocabulary that I had at a young age. And, at the time we didn't have these type of programs and this, the wide resources that are out there now. So I encourage you ladies and young people to kind of take advantage of what you have, your resources that you have with you, and kind of run with it yourself. Always be curious because it starts with you first, and be your own advocate. You may not know what you want now, and you don't know how the path will look, but if you keep exploring and advocating for what you want, you're going to run into some bad choices and learn from it, and then you'll run into some good choices and learn from it. But you'll kind of learn what you really want and what you want to do in the STEM field, and you'll kind of find where you land in your little home. And that's kind of how I did mine. Go ahead, next slide. So the benefits of engineering. So entering this field, I have to say I'm really proud to be an engineer. One of it is I'm I'm a part of history, man. I can say I've worked on the James Webb Telescope that's going to launch at the end of this year, and all the things that are going to be associated within the news. Like, that's right. I worked on that. I made sure something didn't blow up. Yes, that's a good thing, and also like not only just space, other things that I've, as an intern or just things in college, some research projects or any other things that I've worked on the side, right? Because it's not just school you're going to be doing this for. It's kind of like a wider sense for yourself to learn and just get experience is helping mankind. Engineering has made things more convenient, like a microwave. Instead of waiting for things to warm up, you have like a 4-minute warm up in your microwave dish. Or, putting someone on the moon. Like, I'd be proud to work on the Artemis program, which is the first moon mission with all women on it. Like, that is very impressive. And, it's just a little bit of our pride, but, you your programs and the things that you work on, they kind of become your own, and you'll kind of enjoy what you do. Some personal and societal benefits of having people in that field. I have to say, learning how to communicate in the STEM field is a game changer. Definitely when you're out talking to your friends, your family, and things like that, you talk very casual lingo. In the professional working field, and especially in engineering, you learn how to tailor your speech such that it is precise and concise, and you got to get your information as quickly as and then efficiently as possible to whoever your audience is, because everyone's busy and they want to get to the meat of it. And so that's kind of something that I've learned that I didn't necessarily have with other people, that my home didn't kind of have that, and I'm still working on it too. But it's kind of interesting how communicating in the engineering field is versus out in the regular world. Also, the thought process. I'm a very linear and logical person to think in my thought process. Engineering definitely, or the STEM field, really streamlines it. You're going to start to kind of think the same way in your everyday life. Like, I already, when I was in college, I was thinking that way. But, when I'm applying this like 8 or 9 hours a day, you kind of apply it to everything in your working life, your home life, and everywhere around you. And, it kind of helps you become a better world solver out in the real world. You can take some of these skills and translate them out into the real world that might not necessarily you learn from other people, but you kind of learn as you go along in your own journey. And definitely the technology, that is a bonus. The more I'm working in this field, the more different programs that I see. Some are obsolete and some are new. And, things like the Apple products. Look at I have pictures here of the old computers, and now we can do everything that was on these big desktops now on our little bitty phones. And so, some of the things that come out, and just some of how quick and efficient things are becoming, everything's getting smaller and better and faster. And so it's just kind of interesting to see the evolution of how technology is. And I'm excited to see where the future goes in terms of technology and seeing what happens in the news. It's really important to get a diverse group of people, and especially young women, into this field. You are our future. And, once you guys get into the workforce, you will be teaching my generation and generations before me how to be more efficient with new technology. You guys are going to be at the prime and A game of these new technologies, this new software, the new thinking, and you're going to be closer to college, where there's a lot of R&D stuff, which is research and development, things that are going to be right there. You're closer than probably some of the working force, and just by age, you're going to teach us how to be faster at our jobs and do things a lot easier than what we thought. And just the new software that I'm seeing, I'm teaching our more senior staff how to use programs and how to do things a lot more quicker with just the new technology. And we got to see more diversity in the group. You know, it's great to see women, and I'm on a team of 100, and I think there are 3 women, including myself. So I'd love to see more faces in these meetings. Next slide, please. So for my advice for you, be curious, always be curious. It starts with you. If you're not curious, that's okay too. But to kind of get into this field, especially if it's a male dominant field, you got to push and you got to be your own kind of self. You got to be a little strong in this kind of field. No one's going to hold your hand really, but kind of walking through, you may not know everything, but asking the right questions, finding the right person, starting to network. A lot of the things that I've known is just networking. I don't really know a lot, but I know I network and I know the right person to ask and get those answers. Secondly, study really hard. Get really good at your math and science. Those are your bread and butters for wherever you go, whether it's like engineering or coding or the hard maths or being a doctor. Your bread and butter, we all start with math and science. So make sure you're diligent about knowing just the fundamentals, because it all builds up. How can we find interest in which STEM fields they want to pursue? Well, like these talks, you get to hear a diverse group of people, their different fields, where they work, what do they like, you know. Also, go talk to other people. Are there people around you who are doing this as well? Kind of find out what they do, right? Or go and read. We have access and a lot of resources now to the internet. Type in, you like to do something, see if there's a job about it, and find out what those positions are, and then start it. Kind of like a rabbit hole when you kind of go into the internet. Like I get stuck in Reddit or something. It's kind of like that. And watch videos. Like go on YouTube. Like in college, I used to watch engineers, the theory about roller coaster engineering, because I kind of thought I wanted to do that in amusement parks, and it was fascinating to see how the designs work, why certain things happen on roller coasters, what are the physics, and it's kind of a watered down and it's palatable. It's something that I could take in as someone who's just like, oh, this is a lot. But it was enough to stimulate something in my mind to say, all right, I want to continue this route. I want to know. And you don't have to be an expert in anything. Just kind of poke around. You'll see what you like, what you don't like, and you'll kind of adjust your journey to that. What are some of the best ways to power through self-doubt? Well, for me, I first cry because I cry. I'm a crier. And it's okay to cry and say things that are hard, because life is not easy, as you all know. Then take a break. Maybe you need to step away from it. It's okay. But I know we always want to push harder and harder, and that's just kind of the mentality. But you do better and you're more productive if you're kind to yourself. And sometimes you do fail, but you're going to learn from it. And I can tell you from experience, I have failed a lot. And I have learned from it, and I've taken that to my career, and it's gotten to me where I am now. And sometimes, just to let you know, there will be progress that will be made every day. If you show up every day and do a little each day, from where you started to where you are in like the next year, you're going to realize there's a lot of progress that have been met. Definitely. Um, and I loved how this is one of the topics on this for advice was extracurriculars. I think it's super, super, super important for you guys to have a good work-life balance or school balance. You are more than just your career. You are, maybe a daughter or a cousin or a sibling to someone. I want to make sure, you have some fun stuff to do outside of work as well, or whatever you're learning. But hey, if your hobby is also part of like the major and the things, the route you want to go in.
Yeah. Hi, everyone. Thank you for having me. My name is Roshini Bamnwarachi, and my field is computer science. If you can go to the next slide. Thank you, Angela. Yeah. So I work as a software developer for Farmers Insurance currently. So some of my interests are hiking, I play tennis. No matter how much I try to stay away from computer screens, I love watching movies and TV shows. So I do that a lot, and I like reading as well. So one of the interesting facts about me is I used to have a lot of pets growing up. I was born and grew up in Sri Lanka. I actually moved here 6 years ago. So back then, I didn't live in an apartment, so we had a house. So I had all these pets, and so I even now I have a tiny little fish tank, so that you can see in the bottom picture. I have 4 fish in there, so that's sitting there in my room. So whenever I need to take a break, I look at that. Can you go to the next slide? So as I said, I work as a software engineer, specifically in integration systems. So in college, I studied both hardware design and software development, but currently I'm focused on more into software development. So what we do in integration systems is that we connect two different systems to communicate with each other. So for example, let's say that you want to buy something from Amazon. So you put it into your shopping cart, right? And then you go to check out. So in that scenario, the Amazon wants to see, hey, can this person pay for this stuff? Is this a valid credit card that they're using? So they make a quick request to your bank and ask, hey, can you check your records and find this information for me? So your bank actually goes to your records and say, hey, yeah, this is a valid credit card and this person has enough money to pay for it. So that is an integration between Amazon and your bank, let's say Bank of America. So those are the connections that I build at Farmers Insurance with various different vendors. For instance, if I tell you, and a specific one that I do in Farmers is that, let's say you want to buy an insurance, right? So let's say you go to an agent, the agent will ask, give me your ID, I want to see how old you are. So the agent also wanted to validate if your ID is an actual real ID. So that he would take a picture of it, and then that picture would immediately go to the DMV, and DMV will say, hey, yeah, this is a valid ID. So that is one scenario that I've worked with at Farmers. So these software pieces that make this connection, they're called APIs, application programming interfaces. So these things you can see anywhere currently whenever there's a connection between two softwares. For instance, we all use social media. When we upload a picture to Instagram, we want to share it with Facebook. That is an integration between Instagram and Facebook. So there are so many APIs that work behind the background, behind the websites that you work with, behind the software that you have, building those little connections, making this communication, making the data flow through these different systems, making your data secure. So all these scenarios, they take care of it. Can you go to the next slide? So my journey into STEM. So it's interesting that I have the same picture as Tina. So yeah, I got interested in STEM during my middle school. I was always fascinated with science and math. I wasn't that good into math back then, but I was always curious about about the environment around me. I always had these questions, about the stars or galaxies and all that stuff that that's nothing to do with my field, but I was very curious about those things, and science always gave me a start or some kind of answers. And specifically for computer science and IT, as I said, I grew up in Sri Lanka, where the technology, compared to America, the technology was really not that advanced. I still had a computer at my home, believe me. It wasn't that common to have a computer at home back then, but I still did, and I really liked working on it, even though I really didn't understand what I was doing. We didn't had internet really that internet wasn't that common, so we had those encyclopedias that I used. So so I so I remember whenever somebody comes, I would just start my computer and show all those little things. So I used to play around with it a lot. So since it was only me, whenever there's an issue or a problem that comes in my computer, only there was nobody to really help me on it. I had to play around with things and fix it. I did more damage than fixing, but it was all part of learning. there was countless times I had to like completely erase everything and install everything again. That was the final solution. But yeah, so yeah, I started my college career in 2015. I graduated in 2019. I went to Cal State Northridge. So it really was a very, very great experience. As a lot of panelists here mentioned, there's not really that many women in STEM. One of my professors actually used to say, girls, you guys who are in STEM, you guys are like unicorns, you guys are rare. So that's really says in volume like how less women there is, but really there's more and more women in the fields, and I'm pretty sure in the future there will be many more. And I was part of many student clubs. SWE is one of them, and I met these wonderful other colleagues, wonderful women. If you ask me what is the best experience in college, is for me is meeting all these women. These people are still part of my life. They're my friends, and they're the people that I go to when I want to talk to or career advice. I learn a lot from them. For instance, if I want to find out what is it like to work in defense, I have friends to ask that question. So, these are first-hand experience and invaluable connections that I have and I treasure. Can you go to the next slide? So benefits of computer science and engineering. So computer science and engineering is one of the fastest growing. I mean, STEM in general is one of the fastest growing fields, but if you look at computer science, I mean, computer science is everywhere. I have a degree in software engineering, but I work at the insurance company because, every company has an IT department, every company has a research department, because without growing, without implementing technology, a lot of companies can't really grow. They can't fight with their competitors. They have to invent new things. They have to give better products to their customers. So technology is in the heart of all of that work. And STEM workforce is really essential in this sense. And STEM jobs are great. They have a lot of benefits. And in terms of my work, one of my favorite things is flexible time and work from home option, because so sometimes, I'm not that motivated to work. Sometimes at 4 o'clock, I'm like, I'm done. But some days I'm very driven. I'm like, yeah, I don't want to finish at 5. I just want to finish this. So I work until 9. So we really, have that. I really have that flexibility to work on my own hours. And, as long as I get the job done, they don't really care when I do it, where I do it. It doesn't really matter. So I really love that part about my job. One of the other benefits is that it really improves your critical thinking skills. Like any subject that you learn does it, but STEM in specifically, they really sharpen your critical thinking skills. They really make you listen. Hey, do I really have enough data to decide this? Am I seeing all the different scenarios? So all those things, even if you're not a STEM professional, these things are really valuable skills to have as a professional person, and even in your personal life, these are very valuable skills to have. And we are lifelong learners. This is one of my favorite things. A big part of my job is, constantly learning. Whenever I get a new project, like I'm still new to my field, but so many times I have no idea how to do certain parts of my job. So, we learn and we do it. So it's constantly like that. Even the most smartest people I know, the most senior people I know, learning is constant part of their job. They always say that, if you're not learning, then you should, do a different job, because it's part of the fun. It's part of the growth, and you constantly have to grow for your own, and to get more experience. So why is it important to have girls in this field? Why we should get involved? So this is one of my favorite questions. I mean, why not? Because we all can, because we all have the capacity and the potential. But more importantly, I mean, we had a lot of panelists here who are from all the different career fields, and there are a lot of projects out there that shape your future. There are a lot of companies that are out there that build highways, that take people to Mars. So all of these projects, all of these companies, they're shaping our future. They're shaping your future. and they're solving the biggest problems of the world. Climate change, pandemics, everything, you name it, science is there. So to get to better solutions that work for all of us in the world, we need more diversity. We need women, specifically women. So it's a proven fact that when there is diversity involved, we get better solutions because we get new ideas, we get new fresh perspectives, we get more experience. So it's really considering how much a good community that we have. This is a really good time for anybody to get into STEM. It's really, if you have interest, I say please pursue it. Even if you don't want to be a STEM professional, you can still learn, and it'll be a different experience for you, and you will definitely be making a difference. Can you get to the next slide, please? So I love these questions. Okay, so let's see what girls can do to further an interest in STEM. So if you're in high school or middle school, actually I didn't go to middle school or high school in here, but if you have a robotic club, if you have an IT club or a science club, please be a part of that, because getting involved to extracurriculars, as many of the panelists said before, is very important. It gives you a hands-on experience, and it gives you, you're gonna meet like-minded people, you're gonna meet a community, and that is very important for your journey. So there's a lot of online apps too that you can use. So there's one that it's called Scratch. It does a lot of background work for you, and you can design apps, create apps, little games. It's a really good introduction to coding if you're interested. And one of the most important things is reading. If you like reading, if you're currently, doing reading as a habit, please keep it up. You're gonna do a lot of reading in your career. There's so much reading, and so it's a great habit to have. So how can you find your interest and which STEM field they want to pursue? This is a good question. So I would say definitely the more you know about the field, you can get a better idea about it, and try to find out. So there's a really good series that's called The Day in the Life of. So it tells you how a day looks like for a NASA engineer or a civil engineer that builds roads. It tells you what do they do nine in the morning, what meetings they have, what are the projects they look at, what are the tools they use, what do they do when they have questions, do they have mentors? So all of these things they tells you. So the more you know what it is like to be that person, I think it'll help you to decide that. So that's definitely a good video series to look at. This is one of my favorites too. What is the best way to power through self-doubt? We all have it. We all have self-doubt. I check my work sometimes like 5 times. I check it next day. I check it morning, evening, because we sometimes do make mistakes. Let me tell you, it's unavoidable to you can't avoid mistakes. We all make mistakes, and it's actually an essential part of our journey. We learn from our mistakes. We all struggle. We forget things. Even the even the slightest things, sometimes we forget things. But
wow, thank you so much. Oh my goodness, you ladies have just explained so many things that are very interesting, both Rebecca and Roisin. So I have a question. I know some people may have questions. Let me go first. I wanted to ask both of you, Rebecca and Roisin, what really drives you? There's that commitment, from when you're young in your career, because most women, they also just hint, especially those that are trying to pursue STEM, they think they can't make it. So what commitment can you advise to the young girls that are growing? How committed, and what drives you to be committed in that way?
that's a very good question. What committed me? I'm a very results driven person. So, whenever I make progress, that is really my motivation to continue. This is not necessarily means the result that I want to get, but whenever I make some kind of progress, that is really my biggest motivation. So let's say that I have let's say I have to design a website, right? So if I just get a page up and running without nothing on it, that's the progress. So that's I did something, and that is some of it. So I don't take a big challenge as itself. I try to break things down and break into little steps and trying to achieve smaller portions of it, and I call that a victory. So that's how I get along. Yeah.
Wow. And Miss Todd, Rebecca?
Yeah, I kind of agree. Just baby steps. Sometimes if it's like a task is too big, do something really small in the day. And if you're like, it didn't break, success. Sometimes our biggest successes are small steps. I think maybe it might be the American way or something where we want to see big leaps and bounds, but that is not realistic. It is an everyday grind. And if you just show up, some days are good, better than others, but I want to encourage each and every one of you that you can do this, and it just takes time, and don't be too hard on yourself. And sometimes it's mostly us in our own heads, because I guarantee you everyone else is feeling the same way and they've been in your position. And don't compare yourself to people who have more experience, because I guarantee you if you ask them what it was like at the very beginning of their career, tears were flowing like a river for everybody.
All right, I'll pass this to Angela.
Okay, so there are some questions in the chat. You two can take turns answering them, but first question is, do you know of any helpful middle school clubs or programs for girls interested in technology or computer science? And Danielle, you can also answer as well.
I guess I can go. Some nice clubs, as I mentioned when I was talking, Girls Who Code definitely. People usually they start their own chapter at their school, or maybe your school already has a chapter, and I would recommend joining that. I'm not sure if they do that for middle school, but I know for sure they have that in high school. And also for robotics, First Robotics is an organization and they have multiple competitions. So one of them is the first Lego League or something like that. And I know that is in middle school.
So I feel like Danielle had the best answer for that. I think I don't have too much for that. It's been a while since I've been in high school and middle school. And when I did do high school, I think the only thing that was there for me as a female to engage in like the STEM was either an AP course where you had to go to another campus, or the first robotics, but they were still in their infancy. And so I don't know about that, but I think they've matured, and I think those are good programs to join if you could.
Yeah, I didn't attend middle school or high school here, so I believe what I experienced was very different. But we also had like something called exhibitions or science fair, so I was a part of all that. If you have any of those sorts, they're going to be definitely good experiences.
If you want, you guys can continue answering any questions in the chat.
I think there's one question that says, what challenges should female look out for when they enter the technology area of STEM?
That's a good question. I would say not just females, but anyone in general. So for me specifically, when I first started my job, I felt that compared to what I learned in school, the industry is like 20 years ahead. So we learn basics in school, we learn these very fundamental technologies in school, because that kind of makes sense. You have to learn your basics, you have to start from simple. But when you go to the industry, they have kind of latest technologies, like it's a whole another thing. So there was a big learning curve, and I kind of felt that a lot of things were new, and every company has their own kind of vocabulary. I would say they have a lot of acronyms. So sometimes when I go to the meetings, I didn't understand a single thing. So it really takes some time to blend in. And one of the most helpful things that you can do is ask help. I didn't do that as much as I should have done. People really willing to help answer your questions. So definitely ask for help and ask if there's any documentation for new people. So just keep going at it. It'll make sense after a while, but initially it will be a struggle. But it's how it is for everyone.
Miss Rebecca?
I want to agree and piggyback off of the last answer. Just in terms of anyone, what you see in school is all cute and fun, but when you go into that real world, oh, it's like a slap in the face with cold ice. I don't think anything will really prepare you for the real world or the workforce unless you actually experience yourself. And it's good to have all these resources right now to kind of learn and to kind of get experience in that way. But as soon as you kind of get in that workforce, get in your position, a lot of this will be hands on the job, and that learning curve is steep. But again, just be really kind and don't compare yourself too much to senior engineers or people around you, because you all start somewhere and it's going to be a difficult and bumpy ride for, an entry person. So don't be discouraged and continue on, because you'll make it through.
Wow, that's interesting. I just wanted to say, I remember when I went first to start working at Northrop, and I went into a meeting with my team, and they were all abbreviations: TL, TP, ST.
Mhm.
I'm like, and then, they don't want me because we're in a meeting, and then they say, okay, it's your turn, Kirsten, to say something. I'm like, I don't understand anything. So it's okay to first go into a place where there's technology and just be patient and just listen, just absorb what everybody is saying. Finally you will get it. It looks like it's gibberish, but later on you start adding points from one point. You're like, okay, so this means that. So wow, that's interesting. And I wanted also to hear what comment she may have concerning this question.
Yeah. So I haven't personally been in the workforce, but some challenges that I have encountered so far is that I look at the technology field and I realize that there's so many different paths. Like I chose artificial intelligence to talk about, and even in that, there were so many subfields. But really, it's kind of overwhelming when you see how many different ways you can go with technology, and you might get lost, but really, you just have to choose something, maybe stick with it for a while, and you can always switch off if you'd like.
All right, thank you so much. Angela, do you have any questions?
For now, I don't think I do. So if anyone else has any questions, you can put them in the chat.
Maybe we can wait for a few minutes to see if anyone has questions.
I think earlier Gloria asked the question about the changing technology field. So I can go ahead and answer that. So again, I haven't really been in this field for a long time, but I do see the changes in it. And like, again, I read newsletters and that kind of thing to sort of keep myself updated. And it's really interesting. Sometimes it is hard to keep up, but when there's like a lot of big breakthroughs in technology, you'll tend to see it in a lot of places.
Yeah, to add on that, yeah, technology does change so fast, but in my experience, when it comes to programming, the basics of programming remains the same. The things, the very, very fundamental basics, they remain the same. It's just how we make things work is how it changes. So again, like your basics, not gonna really gonna change that much, but you know, there are certain things that we never really have in our head. You know, we just Google and find out how to do certain things. So that's the part that changes. And the more you advance in your career, it becomes very specific. So you're like become kind of expert into a very specific part of your career. So in that case, you know, you do only research onto, you know, how to, you know, research on that specific part. For instance, for me in API development, right, I might be, you know, searching into how to make things secure. So in that case, I won't do research on like semiconductor stuff like that. So it become more and more specific. So there's not really, you know, it's doable to catch up with the latest changes. Also, when you work in a company that you, at least in my experience, you we get a lot of other companies to work with us. For instance, some other company is in charge of handling security for us, stuff like that. So you know, so we don't have to, you know, so they do some kind of research for us. It's just like, you know, we discuss and kind of implement certain things. So it really depends on your job also. If your job require you to look into certain things, do certain research, it really depends. But yeah, I mean, we do a lot of learning, we do a lot of reading. That's really part of the job.
And just to squeeze in something, mostly when you go, I get a lot of questions from young people. They say, what software are you using at your company? I say, you know what, you don't have to worry about what software they're using. As long as you're an engineer, trust me, when you go to that place, you will learn it. Then are you serious? I'm like, yes. So you don't have to worry and say, because when we're at school, we're thinking, oh, I have to also find out in advance what software they're using so that I can, you know, we start stressing ourselves in that area.
No, I totally agree. Yeah. Even with the programming, you don't really have to learn all these programming languages out there. There's so many. There's Java, C, there's Python, so many. No, just learn what it means to program. Learn the basics of programming, the for loops, the, you know, if statements, encapsulation, polymorphism, all of these basic concepts is what you'll need to learn. How to implement that, how to implement a for loop in Python or Java. That's what we Google. We don't really, you know, remember how to do those things. But when you know, yeah, I have to use a for loop here, I can't use a for loop here. So that is the thing that you have to practice. So yeah, I agree. You don't have to learn the specific software because this change from one company to another also. But your engineering mindset, that is something that, you know, you're gonna have. That is the asset you're gonna have to develop.
I think we've come to the end of the session for today. Angela?
Yeah, I think we are done today. So thank you everyone for coming. We hope to see you all tomorrow too. And thank you guys for taking time out of your day to talk to some of our participants about what you guys do and the experiences you've had. It's been very insightful and very helpful. And we hope you all have an amazing day, get some rest, and hope to see you guys tomorrow at 5 as well.